Hey guys, welcome to Physics 2, Lab 1, Charged Tapes. Today we're going to be going through a decent bit of things about this kind of lab, but this is the agenda for those of you who are curious. The description of this lab is to use tape to observe the transfer of electrons between surfaces and to calculate an estimate of the charge and number of electrons transferred. So basically you're just assuming tapes are point charges and using these physics principles here, like point charges and Coulomb's law and Newton's second law, are based off the force of gravity, and some dimensioning of atoms as well, to kind of help determine what exactly those charge differences look like and how they impact the tape's movement. So it's pretty cool. This is the preview results. The tapes repulsed each other because they carried the same charge as would be expected of point charges. The charge was determined to be positive. You'll see why in a second. And the charge was determined to be 1.3138 e to negative 8 coulombs. And as such, each piece of tape was therefore determined to be deficient of somewhere near 8.37 times 10 to the 10 electrons. Pretty cool. Let's get into why we found that, though. So our assumptions for this lab are pretty big, but they're the fact that tapes are assumed to act as point charges, which is a big assumption, but we'll get into errors behind that later. When in reality, they're much larger. Is to observe interactions. Some other more basic assumptions, like ignoring air resistance and the charge being evenly distributed around the entire tape, is pretty important as well. And the charge being calculated at the center of the tape, as can be seen in this diagram. So our setup involved two pieces of tape, A and B, and surrounding the observable universe, or basically everything. Two pieces of tape equal length, third piece of tape stuck on the surface. Basically, the tape was quickly ripped off of the surface in order to leave behind some electrons and cause it to be positively charged, or potentially gaining electrons. So that's kind of like the thing, is like figuring out which is which, right? It was placed above the other piece of tape to see like how it would react. We can see that this tape was attracted to skin, glass, wood, and a negatively charged metal chair, implying that it couldn't possibly have been a negative charge, meaning it must be a positive charge. It was repelled by more U-tape that carried a similar charge, therefore it must be positive. And in doing so, being positive, it must have lost electrons during this entire process, right? Let's do some calculations. We know that our tape mass, based off of some standard stuff and just weighing it, it's 0.00022 kilograms, which is not a whole lot. Its length is kind of approximated based off of this, but this is about what we got it to be. And the distance between the tape is 0.0268 meters right here. So this is that difference right there. So in order to determine charge and the electric force, we can assume it is equal to the force of gravity. So you can use G times the mass of the tape to figure that. And there's no other forces acting on it, kind of based off this charge. It has to be equivalent, right? And knowing that force, you can plug it into this formula right here. It can work backwards to get the charge. And that charge can be determined to be a positive charge of 1.3138 e to the negative 8 coulombs. That's really important later on. Let's continue to see how that charge is used throughout the rest of the experiment. So knowing that charge, we can divide that to be the charge of a single electron, right? So we can divide this number here by the amount of electrons, which is pretty important. And we can kind of figure out like how many electrons were lost in order to gain a positive charge of that standard, right? Because we were assuming the tape is perfectly neutral at the beginning. And this is, we get 8.212 e to the 10 electrons, pretty important. And we can use this information actually also to determine kind of like a surface area thing, like how many electrons are lost per each atom, which kind of just helps like determine from a material standpoint what's practical and stuff like that. So you can do it with this math here, and you get 1 electron for 4.8709 e to 6 atoms. Pretty cool. This is glow script code that kind of helps visualize this and calculate it to a more efficient degree. You can see that Q is equivalent to this formula right here, which you can see right back here as well, right? Pretty cool. And you can do some atom counts by knowing the length and the width of some of these surfaces and whatnot. And then these objects and spheres things are to just provide visualization. But there, of course, are some errors to this. So it's a very bold assumption to consider the large pieces of tape as point charges, because they are large pieces of tape after all, as charge is not entirely evenly distributed among the entire piece, right? And Q is also not likely the same for each piece of tape, even though we can assume both were positive based off of their reaction. Some was likely lost to environment due to factors such as wind, or, like other small electrical forces, maybe some mishandling or things along those lines. Discussion questions. These are pretty important. So what if electrons had positive charge and protons had negative charge? What would change? Well, if they kind of switch, nothing would change. It's just you would call them different names, right? So the exact same response would have occurred, even if it seems like something would change. If you're changing both, that would be different. Now, if you were to change only one of them, that would be slightly different, and you would cause, I don't exactly understand the full extent of what would happen, but it would most likely cause some attraction between the tape or nothing to happen at all. Another question, why is it important to handle the charged tapes as little as possible? That's because there's a lot of factors going into the fact that when you touch the tape, you're transferring charge from your neutral body, potentially, to it, and that causes it to lose charge and you to gain some charge, meaning that the inaccuracy between the two tapes is going to be much higher because of that. It can polarize and effectively stealing the tape's charge. So that's the main thing. Thank you so much for listening, and I hope you have a good day.